So, ladies and gentlemen, let's meet our second speaker for today. And it is, of course, a professor in computer engineering from Kuwait University. It's Dr. Ebrahim Alrashed. Welcome. Good morning. This morning, he's going to be presenting on the subject of IoT for control systems and cyber security. Over to you.
Hello? Can you hear me?
Have you switched your box?
Yeah. Assalamu alaikum. Sabahak wa khair. Good morning and welcome here to this session. We're talking about Internet of Things and cybersecurity today. Okay, so we're living in a digital world where we are surrounded by digital devices all around us, whether it's iPads, iPhones, laptops, digital cameras, even our cars, digitizing our daily life, digitizing our every movement. For example, you have an Apple Watch that measures the number of steps that you take. You have a digital camera that it captures your emotions. You go to Facebook, your mood, your like, your dislike. We are digitizing everything that's surrounding us right now and converting that into data. So everything is being converted to data, even the shirt on our back. So we have this company called Hexoskin that you have a smart shirt that measures your heartbeat, your breathing pattern, your body heat, and now you can infer whether that person wearing that shirt, if he's stressed, is he relaxed, sleepy, tired. You can infer all these things from that shirt that he's wearing. So we're generating a lot of data. So Cisco, 2015, gave us the statistics. They said 1.1 billion data points generated by sensors daily. 1.1 billion. They said 500 gigabytes of data generated by an offshore oil rig weekly. They said 1,000 gigabytes of data generated by an oil refinery daily. They said 10,000 gigabytes of data generated by a jet engine every 30 minutes. So all in all, we're generating 2.5 billion gigabytes daily. To put this in perspective, we generate 90% of the data, of the world data in the last 2 years. So we're generating a lot of data. But what's data? What's a measurement? What's a temperature? So if we take a measurement of temperature right now, it's 26. Okay, so what does that mean? How useful is that one measurement of data? It can be useful, but it's not as useful if we put it in perspective. So if we take for example, global warming, if we take the measurement of the average global temperature over 20 years, 30 years, 50 years, now that's information. Now we see a trend. It's more beneficial, it's more useful, that data that we make out of just instead of just one piece of data. So data is useful. Data in context is more useful. Now, if we take this information that we get and we reach to the stage of knowing why this happened, now that's knowledge. Now, so if you take a temperature and you take the wind speed, direction, pressure, and then you put all this together, now you know how hurricanes, for example, happen. That's knowledge. You take it one step further to reach wisdom, how to deal with that knowledge. So if knowledge is the know-how, then wisdom is the know what, the know when, and the know who. What to do and when, and by who. Right? So data is important, but reaching that wisdom is more important. Okay, so what's Internet of Things? Let's look at the definition. Internet of Things is the interconnection via the internet of computing devices. Okay, simple enough. So IoT connects assets, people, products, and services. They connect them together. So if we have, there's one product, they have a smart vase where you have a plant with a watering pipe, and then you can just control this remotely. So you're traveling, you're going to London, you just log on to your app, and then start watering your plant. Well, that's IoT. Good for you, that's IoT, right? But is that really what we're looking for? Is reading a temperature, right? Reading a temperature, and if it's hot, then I just, in Kuwait, for example, if it's hot, then I'll just lower the blinds of the windows, turn on the AC, right? Is that Internet of Things interesting enough for us? Yes, but that's in the realm of home automation. I challenged my students. I said, give me something in Internet of Things, right, that will make us really, really, really happy. One student said, I want to sit in my desk, in my office, at work, and when I stand up, my chair recognizes that I'm not sitting anymore. And when I walk, my chair will talk to my office door to open it up for me. And then I just walk, and the door talks to the elevator to call up the elevator for me. And when I get into the elevator knows where I'm going. And then the elevator will call or contact my autonomous car. And my autonomous car will get out of the parking, turns all the way in front of the building, and opens the door for me. And then I just sit in my car, and then the car will see what the optimal route to my house without lifting a finger. Is that doable? Is that doable? Yes, it is. Yes, it is doable. That would make our life lazy, right? That would make our life lazy. But that's an example of how efficient, if waiting is our metric here, then that would be efficient because I'm not waiting, I'm just walking and doors open, elevators go, cars come, I just get in. All I have to do is just walk and things happen around me, right? So IoT can increase efficiency, can hide performance. But, in my opinion, if you really want to capture IoT, if you really want to utilize IoT to the next level, you need to tie it up with big data, especially in your industry. You have to tie it up with big data. What's big data? Well, every single data that the sensors in your ICS system collects, you put in a cloud, that's big data for you. Now, if you apply analytics to it, if you apply machine learning, artificial intelligence, if you apply analytic algorithms, expert system, you apply these things. Now you go from data to wisdom. Now you go from data to scenario planning. This is how you can be more efficient in your operation. Okay, for the ITs of you, IoT is a layered stack of protocols just like in the internet. But we don't use the same protocols because IoT devices are limited in their processing capability, memory capability, even their operating systems. So we use protocols that are streamlined, lightweight protocols. We don't use HTTP, we use MQTT. We use CoAP, we use lighter versions of the protocols. I'll come back to this stack later on when I talk about security issues. Then we have this question, is it hype? Gartner have this hype curve. They say technology goes through this curve of hype. Introduction of technology goes, everybody hypes it up. We engineers hype it up. Researchers hype it up. Media hypes it up. Goes on top of the cycle. Then just comes crashing down and then leveling off. Gartner in 2014 had Internet of Things on the top. It's hyped. Everybody's thinking right now, Internet of Things is the solution to all our problems. It will just disrupt the whole industries, whether it's oil and gas or everything. We'll just disrupt it and then just change everything. But is it true? I love this quote from Deloitte report. They said, IoT promise lies not in helping oil and gas company directly manage their existing assets. So it's not managing your assets, it's creating a new asset called your information. So it's creating information. That's a new asset. If you have information coming, your sensors in your ICS systems, if these sensors generating data, and you have your data, and if you are not utilizing them, then you are losing on a lot of information, a lot of capabilities that you could do, a lot of potential that you can harvest. You're losing. IoT's promise is leveraging that information. So, IoT, well, you have devices, and the lower of the pyramid, remember that pyramid? At the lower base of the pyramid, that's your devices generating the data, and then you need to have your analytics way on top to reach that wisdom part. Oil and gas, well, they have a lot of challenges, oil and gas industry. Remote sites, you have an oil well north of the country, south of the country, you have offshore, you have on land, you have a lot of remote sites. You're operating based on $50 per barrel. Right now, you're kind of stressed financially. You have safety regulations to limit and reduce the number of accidents and fatalities and God forbid, and everything. You have hazardous areas, refineries, chemicals, a lot of things that can go wrong and cause loss of life. You have security. Now we know oil and gas is being really an attractive target for attacks. And then you have industry regulations like the Paris Accord, where you have to limit the gases released to the atmosphere. And then you have a shortage in technical skill and labor. Now, these are the challenges. Now, can IoT solve these? Can IoT solve these things? Well, we know oil and gas is highly automated already, so it's nothing new to say, well, you can connect one device to another. You're using telemetry, and Dr. Reem yesterday said that KOC, they have this digital oil field. Shell, I think they had it like from 2008. So we are kind of connected. What IoT can provide is increasing that coverage of connectivity, where you can not just connect an oil field, you can connect the upstream, the midstream, the downstream, you can connect your logistics, you can connect everything together, get all this information together to increase your efficiency. For example, just a basic example, you know your industry more than I do, but I'm not from the oil and gas industry. Sending tanker trucks of petrol to petrol stations, right? How is this done? If we can have sensors over there, tell us when to send, at what level their storage is, and then kind of tie this up with our ERP system and generate the sending of the trucks in a way that optimizes the number of trucks that is roaming around the country and the number of drivers that's roaming around. We can cut costs by using the sensors, and we can do this totally automatically without even the intervention of anybody. Well, this is a picture of how a digital well can happen. You can have sensors for everything. We can build sensor for any data that you're looking to manipulate. We can build a sensor and we can send the data for you. This is no problem from the engineering point of view. Okay, one of the things that IoT can give to the oil and gas industry is predictive maintenance, for example. Or predictive anything. Predictive maintenance. Well, predictive maintenance is the opposite of calendar maintenance. Calendar maintenance says, well, every 6 months I have to take that piece of equipment off operation, maintain it, maybe change some of the parts, and then return it back. Well, some of the parts can go 3 months more without needing to be replaced. If I use sensors, now I will do the maintenance when I need it, not by schedule. Hence, reducing the downtime and reducing the cost. I will not be throwing some parts that they can go even longer without premature maintenance. That's the point. So we can integrate our information. We can collect our information in our private clouds. We can apply analytics. We can get all these data, and we can take action in real time, reducing the involvement of personnel in hazardous situation, hazardous areas, and really capitalize on this technology to reducing our cost. For example, Maersk Drilling and GE just announced they're cooperating by installing from 250 to 1,000 sensors in the vessel, the drilling vessel of Maersk. 250 to 1,000 sensors to automate and optimize the offshore drilling process. Their target, 20% maintenance cost reduction. 20%. Shell had a problem in Nigeria. They have 80 oil wells in Nigeria, rough terrain, cannot go there, cannot have people stationed in that area. Cell phone coverage is not really that good. What they do, they employed IoT with low power radio, long range, long power radio, and they just covered all these things with the cost reported as $87,000. The estimated return on that investment is $1 million by employing it. And they read real-time data remotely without having to station personnel at the oil field. So you'll end up with, if you apply IoT, you'll end up with an oil company with something like this, connected every facet of its operation. It's connected. Okay, but it's too good to be true. There's got to be a catch here. The catch is security, of course. IoT is security. We love IoT. I think it's not a hype. I think if you combine it with big data and analytics, you will just get great return on your strategy. That's beautiful, but you have to fix the security part. Okay? When you introduce a new layer of equipment around your network, you're just increasing the surface area of cyber threats. Now, attackers have other means to attack. You just gave them a bigger playing field. Oh. Okay. So, what is at risk here? Well, the data of the devices, the Internet of Things devices, the things, their data is under attack. Or we can manipulate the data while it's being sensed. So even if your sensor is well authenticated, we can manipulate the data being sent to begin with. We can play with the data that's been sent, with the integrity of the data being sent. So data can be attacked. Protocols, that's why I showed you the protocol stack. Protocols, new protocols. TCP was used to attack the internet, right? To attack servers. Protocols of Internet of Things can be exploited also, right? So we have to work on this. We have vulnerabilities in operating systems. It is reported right now is 60% of all things manufacturers are running over Linux. Right? Microsoft is pushing its Windows for things, and Google is pushing Android things. They want to get into that space. But 60% is Linux right now, and just last week, it was announced there was a Linux malware that is found that affected one manufacturer's whole line of things, of sensor devices, based on Linux. So how do we mitigate these risks? Well, when you do your IoT strategy, security has to be front and center. Security should not be phase two. We should not be, let's build an IoT infrastructure, then we'll secure it. No, no, no. At front and center, at the beginning, you have to think, you have to make that discussion at the beginning. You have to worry about things, authentication and replacement. Some devices are battery powered, charge will die out. If you just forget about your sensors and they just die out, well, you can run the risk of attackers placing fake sensors in your system. You have to have some kind of authentication and replacement management scheme. You have to do patching. You have to do patching. The Internet of Things devices will be an afterthought after a while. You'll have 10,000 sensors, you'll just forget to patch them up. They're based on operating systems and some software. Your manufacturer should maintain, or upgrade their software when they find vulnerabilities and patch them, and you have to patch your devices too. It's just too much of a risk to just leave them like that. You have to have infrastructure, the IoT, the OT, the IT. This is just basic recommendation. You have to assess your security all the time. Let me give you an example. You have a thief, you have a house, you have a fence around your house with a door, and then a thief jumps in, steal your chicken. Right? You just go back and just put a lock on the door and say, I have put a lock, I've secured my house. Right? And every day you go and check your lock. Every day you go and check your lock. It's working, right? But then the thief will just jump over the fence and steal your chicken. Then you say, I didn't think of this. So you just put barbed wire, right? And he says like, now I check the barbed wire every day. Check the lock. I'm done. I'm good, right? I'm secure. Guess what? He can get a drone to steal your chicken, right? You have to be on your toe. Just because you are ISO 27000 certified doesn't mean that you're done. You have to be on your toe. You have to think. They will always be one step ahead of you. They will always be one step ahead of you. What you can do is be just one step behind. Don't be 10 steps behind, right? Don't be 10 steps behind. You have to be at just one. So we need to work out. Let me plug the research community here because I'm from university. We need to work together. Oil and gas industry, you guys need to work with the manufacturers of Internet of Things. You have to engage them. You have to make sure they build secure devices. You have to demand that, right? And they commit on patching of their system. The manufacturers have to work with us, research community, to develop solutions to those problems. And we're doing this. This is IEEE. This is database of our research. This database of our research. We have 2,665 published papers right now in IEEE on IoT security. Okay. I only have 1 minute and a half, and if you don't mind, I just want to give you my 2 cents on the discussion that happened yesterday with the leaders here on the podium. They asked, are we going to converge IT and OT or not? And how can we secure this convergence? And I need to tell you this. This happened before. This discussion was done 20 years ago in the telecommunication field. In 1990, when we had GSM, the switches of call delivery, the switches were controlled by an SS7 network. IP was not involved. There was a total separation of IP and of SS7. Switching network was different, separated from the IT network. With technology right now, we have an all IP network, right? So how did we secure this? Oil and gas should study the telecommunication network. This is what you need to do with your OT and IT. You just study the lesson learned from the telecommunication, the cellular network communication. Thank you very much.